Good morning. Today I am going to start hydraulic pumping as an artificial lift. What is hydraulic? What is pumping? What is artificial lift? Okay, artificial lift, already you know, artificially lifting fluid from wellbore to the surface. Now using hydraulic pumping mechanism, you have to increase productivity of wellbore. And if wellbore is having fluid with gas, with sand, with deviated wellbore, very deep wellbore, you can use this jet pump. The jet pump is having lower efficiency. Efficiency will be like only the pump up part efficiency will be around 30%. Okay, and if you see whole system, then efficiency will be further lower. Now still jet pump people are using because there are some positive aspect which is pushing the industry to use jet pump for their productivity, for the enhanced productivity of oil bore. Some cases they use for CBM or cold bed methane system, or some cases they are using for dewatering gas well system. Okay, but there are two types of jet pump system. One is called hydraulic pumping system, one called jet pump, another is called hydraulic engine pump or hydraulic piston pump. We'll discuss later all these details. So for further discussion, student can watch this video link I have given. There will be several other videos also they can watch, and they can get some basic idea how hydraulic pumping or jet pump is working, how hydraulic engine pump is working, and at the same time I'll be discussing different aspect, mathematical aspect of jet pump and how this jet pump is improving your productivity. So you have to go to IPR curve. So you can remember PWF, flowing pressure is high, that means you're getting very low flow rate, flowing pressure in the wellbore. Okay, PWF and PR. If PR and PWF the difference is very high, you will get more productivity. Okay, so if PWF is very high, you are getting very low flow rate. If PWF is very zero, then your production may be like this. Okay, so if you can make zero flowing pressure at this entry of the wellbore, and reservoir pressure you are not changing anyway, so your drawdown, the difference between PR and PWF's drawdown is high, that means you are getting more production. Now a wellbore is having certain liquid column, and liquid column is creating pressure H rho G. Because of H rho G, PWF is high. Okay, H rho G, the whole pressure is actually PWF. Now if you can remove the fluid column or liquid column, then your H is reduced. Okay, so rho G is fixed anyway, so H is reduced, so your PWH is reduced. PWF reduced means you are getting more inflow from reservoir to your wellbore, that means you are getting more production. Let's say initially your productivity is here. Okay, outflow performance relationship, OPR or tubing performance relationship or liquid performance relationship, they will write like this. And because of jet pump, you reduce PWF, and this line outflow performance relationship crosses this IPR. You got some production. Okay, you remove further liquid using your jet pump, you get further more production because you see this Q is increasing. Okay, Q means flow rate. Flow rate increasing. Okay, and when you are changing, let's say 1 to 2, 1.1 to 0.2, so your PWF is changing like this. Okay, so this much of assistance you are giving to your wellbore so that your flow rate can increase from A to B. Okay, when your PWF reducing from 1, okay, A dash B dash, when PWF is reduced from A dash to B dash, your flow rate increase to A to B. So in this way you are getting more production using hydraulic pumping system. Now you see this figure I have copied from PetroWiki. This is a nice figure actually I found. So this is wellbore. Okay, wellbore, and there is wellhead controller. Wellhead is here, wellhead control is there, and high pressure fluid you are pumping. Okay, high pressure fluid you are giving to your wellbore, and that is increasing productivity. How it is increasing, I'll explain later. Let's say assume one wellbore is there, you are increasing high pressure fluid, then you are getting your production. So this is actually production fluid. Okay, This green color is production fluid. Okay, now you are storing here. Okay, then you are separating. After separation, you are reserving the fluid somewhere. Okay, so this fluid will move to here, this tank. Okay, now this yellow line is showing gas line. Actually, if whenever you are getting some production and you are reducing pressure, some gas will be coming out from your liquid or oil. So that gas you have to handle separately, or you have to send to sales line, or you have to inject some wellbore. So you can handle separately. But whatever liquid you are getting, so from wellbore you injected say water, and you get mixed of water and oil. So on surface you have to separate. Oil will go to refineries. Water you have to dispose, or you have to keep for again re-injection to wellbore. Okay, because same water you can re-inject again and again, but before injecting you have to separate oil and water, because whatever production you got, same produced fluid you cannot put in wellbore. That is the loss of your productivity. Okay, so you got liquid. Okay, then that liquid again you are passing through on pump, high pressure pump. This is high pressure pump. Okay, very high pressure pump you are creating. And high pressure pump, how this pump will be run? You will have one motor, induction motor, and induction motor there will be coupling, there will be gearbox. Okay, then multi-cylinder or multiplex plunger pump or reciprocating pump. Actually this is a plunger pump or reciprocating pump, multiplex or multi-cylinder pump. And when you are getting flow from a reciprocating pump, actually normally it will be pulsating flow. Okay, so later we will discuss what is pulsating flow, how to reduce it. So if you have pulsating flow, then you must have one pulse damper. So that's called pulsation dampener. Okay, so pulsation dampener is here. So whatever pressure flow, like reciprocating pump giving 1 flow, 2 flow, 3 flow. So when piston is moving up, for example sucker pump, you can see when moving up you are getting production, when going down you are not getting production. So if I put one pressure sensor here, when moving up pressure sensor will show high pressure, when piston is moving down it is not showing anything. Again moving up, again it will show high pressure, again going down. Okay, so you are getting pressure pulse like this. Okay, like sucker pump you have. Okay, rod is there. So when piston is moving up you are getting high pressure, when piston moving down low pressure, high pressure, low pressure, high pressure. So you are getting pulse. Okay, so that pulse you cannot put into your jet pump, so you have to reduce the pulse. How to reduce? You have to use some pulsation dampener. Pulsation dampener is nothing but one chamber with some nitrogen inside there with some membrane, so that nitrogen will be compressed and it will be absorbing the pulses and it will be giving smooth output, and the high pressure fluid will be going into your wellbore. Okay, when it is going to wellbore, the wellbore fluid can be mixed with this whatever high pressure fluid you are giving, or it can be separated. This high pressure fluid is called power fluid. Okay, power fluid. So in many cases power fluid and produced fluid, or whatever fluid you are getting from your reservoir, that fluid will be mixed. In some cases that fluid will not get mixed, they will be separate. Now this Weatherford from one brochure I have taken this picture. So Weatherford is having a picture like the system they are manufacturing and they are selling also. You can see this same thing here we have drawn, like separator system is there, and storage system is there. This picture I have taken from one Weatherford brochure. So the picture also shows the same thing. Actually this is one separator system, one storage system. From storage again you are injecting to your wellbore, from wellbore you are getting production. Okay, and production means it is going to wellbore. So wellbore is having, like right side picture, if you see, this is actually wellbore. Inside there will be this jet pump. Okay, jet pump or hydraulic engine pump, hydraulic piston pump. Okay, and what will happen, these are perforations. So from perforations fluid entering here. Okay, and power fluid is coming here. power fluid is coming from inside and power fluid going out, and it is going through this. So this wellbore fluid, if you see this one, this wellbore fluid is going to mix here. Okay, so there will be one mixing chamber. Wellbore fluid will be mixing with your surface pump fluid or the power fluid. I told that whatever fluid is pumping from the surface, that is called power fluid. So power fluid and wellbore fluid will be mixing together, then you are lifting to the surface. Okay. Then see this other picture below. This is actually, this is also from the same document, it was there. So one nozzle is here. Okay, one nozzle is here. This is nozzle. I am shading this one, and nozzle is creating. Okay, this is nozzle. I am shading. Okay, the hollow part I am not shading. I am shading the metal part. Okay, and high pressure fluid is passing through this nozzle, and whenever you are changing cross section, okay, like say P1 here, P2, Q1, Q2. Okay, so at, let's say this one pipe is here. Okay, one cross section D1 and nozzle cross section DN. Okay, so flow rate Q1, pressure P1, diameter D1. Now it is passing through nozzle. When passing through nozzle, you change the diameter. When change diameter, pressure will reduce and flow rate will increase. Okay, so P2 will be lower than P1, Q2 will be higher than Q1. Okay, flow rate will be same, but velocity, fluid velocity will change. Velocity V2, V1. So V2 will be higher than V1. Why I am saying flow rate will be same? Flow rate means if I am using mass liquid, then mass flow rate M1 equals rho 1 Q1, M2 equals rho 2 Q2. So if rho 1 is constant, then Q1, Q2 flow rate is constant. But if I calculate velocity, okay, so velocity equals Q by A. So when area changing, area means pi d square by 4. Okay, so nozzle larger diameter pipe, this that means area larger means velocity low. Okay, V equals Q by A. But when it is passing through nozzle, so area reduced because diameter reduced, pi d square by 4. So area reduced, so flow rate divided by area. Flow rate divided by area means you changed your velocity increased. Okay, so when fluid is passing through a nozzle, velocity will be increasing. So velocity increasing means your pressure will go down. Later I will discuss how the pressure is going down. Okay, in this nozzle you can see this velocity, fluid is going at very high velocity. So that high velocity creating low pressure here. Okay, low pressure. So low pressure created, low pressure will be sucking another fluid. Okay, so when low pressure sucking another fluid, that means you are creating more productivity. How this will work, I will explain later. Again, this information is taken from same document of Weatherford, just to give idea how much size and what the flow rate will be there and what are the criteria for jet pump. A corrosion handling excellent for jet pump because this from surface you are pumping power fluid. So power fluid you give some anti-corrosive agent so that corrosion handling will be easier. Gas handling because jet pump is good for gas handling. Solid handling also very good. Fluid gravity, high gravity also, thick fluid also can be pumped because from surface you are pumping high power fluid or high pressure fluid. So that fluid you give certain agent, increase temperature, so that fluid gravity and all these things will be changed. Servicing also is very easier because only the jet nozzle will be there. You have to retrieve or you have to fix there in the bottom. in the wellbore. Prime mover type, multi-cylinder electric cylinder will be there, offshore application also possible. And if you see this operating range up to 20,000 feet, because PCP and other will be hampering, they will not be able to handle this 20,000 feet, but jet pump can handle. Operating temperature also can be very high, because this jet pump nozzle system, whatever nozzle and system I have shown, that is not having any non-metallic part, it is completely metal. So high temperature also there is no issue. So 260 degree centigrade temperature, HP, HT, or high temperature high pressure wellbore you can use safely. Operating volume 300 to 1000 barrel per day, okay, and it can go up to 35,000 barrel per day. Huge volume you can pump actually. And tubing size can go like 1.5 inch to 3 inch actually, okay. And when tubing size is very narrow, your flow rate also becoming low. You can see this 400 barrel per day, and for high volume your barrel also increasing per day. So jet pump you can use for deep wells, deep wellbore, okay. You can use for high solid content, already solid or sand, gas, high gas also okay. Corrosive fluid also okay. Corrosive fluid, okay, because from surface you are injecting power fluid, so you can use some anti-corrosive agent so that corrosion will be neutralized. Some chemical you can add to neutralize the corrosive action. Subsea production possible, and high volume of production, volume can be high, okay. Short and compact body, so retrievability or fixing, wear line fixing, wear line operations, etc. possible, because only the nozzle part you have to remove or fix. And operation life also very long. Can you remember the PCP I already told, what the operation life? It will be like 4 to 6 months. Here you are saying 4 years about. It's a very long operation life. And it will have surface equipment like multiplex pump like 6 to 5 horsepower, okay. And electric motor or multi-cylinder IC engine can be running this compressor pumping system. We cannot say compressor because you are not compressing, rather you are creating high pressure. Now jet pump is having some limitations also, okay. So limitation is that efficiency very low, 10 to 30%, okay. Power fluid rate also very high, almost double of the production fluid. So high amount of fluid you have to pump, and high pressure handling, also very difficult on the surface, because pipe and other safety issues may come. Space limitation, because on surface you need lots of pumping system, motor system. So if you have space issue, then you may have difficulty of using jet pump. And some other issues like failure issues, for example cavitation will be one issue. Cavitation can be one issue for jet pump application, because at high velocity if you have sand particle you will be eroding your jet pump metal surface, so that will be creating cavitation and erosion, okay. And again corrosive fluid is there, then erosion corrosion will be coupling together to make your life miserable. Hydraulic engine or piston pump, this is actually related to sucker rod pump. So mechanism is such a way, designed such a way the system, so you pump high pressure fluid, okay, then run one reciprocating engine, okay, reciprocating engine, like steam engine. You can, if you go through steam engine basic fundamental, so steam engine actually you are producing engine, high pressure steam you are giving to engine, and your piston moving up and down. and that piston you are creating rotation. So older trains, and even you can see this Darjeeling train or Uti train, some special heritage trains are there. So they are run by steam engines. So that steam engine will be driving your train. Even many places your Titanic ship and many other applications were there. Now the steam engines got replaced, but we got similar application here. We create high pressure fluid. That high pressure fluid will be running one piston system. Okay, so that piston you are getting reciprocating motion. Okay, reciprocating shaft, or rod or sucker rod. So that sucker rod you are creating one plunger assembly. Okay, plunger assembly. So what is that plunger assembly? Actually, if you can remember, the bottom hole assembly of sucker rod pump. Sucker rod pump is having a traveling valve, standing valve. So that same thing actually. TV will be there, SV will be there. So you are creating one sucker rod pump with small reciprocating shaft, and the shaft is not run by your beam or something, it is run by your small engine. Okay, so that way you are replacing your long rod, sucker rod, like big rod was there. So that rod you don't have, you have only high pressure fluid. High pressure fluid is running your reciprocating engine. Reciprocating engine is connected to your reciprocating shaft, so shaft is moving up and down. So that reciprocating action you are putting in your plunger assembly or bottom hole assembly of normal sucker rod pump, you can assume. Okay, and you are getting production. So in that case you are creating reciprocating motion, you are getting production. Okay, so the good thing is that you can go to any depth. You don't have long rod, long beam, or long your hydraulic long motor, that balancing mass and all these things you avoid it here. Only you have surface pumping unit, and you have inserted reciprocating engine and plunger assembly. So it but production rate will be lower than your jet pump. So production lower than a hydraulic jet pump. Okay, why hydraulic jet pump production? Hydraulic jet pump production rate higher, and this is like simple reciprocating sucker rod pump, right? Okay, now sucker rod pump is facing gas issue. So gas and sand issue, same issue will be there. Gas and sand, same issue as SRP, sucker rod pump or beam pump. Okay, but other positive side, for example, it is pumping long wellbore and deviated wellbore. All things can be done using your hydraulic engine pump. So long deviated wells can be pumped. Okay, so I'm mixing up both positive and negative side actually. Low formation pressure also will be okay. Formation pressure, okay. Disadvantage, separated tubing. In the wellbore actually you have to put two separate thing, one for hydraulic fluid pumping, another for production fluid taking out. Okay, so two tubing will be required, or two tubing or two flow path will be required to produce fluid from the wellbore to the surface. Okay, so later I will discuss how this hydraulic piston pump will be having two tubing and two separate thing. Okay, and not mixing your produced fluid and power fluid. So when you are not mixing produced fluid, power fluid, what is happening? So the same power fluid you are using again and again without treating anything. Okay, but if you are mixing, for example, jet pump, you are mixing produced fluid and power fluid. So mixing up, then surface you have to separate. Then again, when you are injecting power fluid, So after separating only you can use, but in this case your power fluid is not mixing with produced fluid, separate line will be there. So power fluid treatment will not be required every time. Okay. So whenever you are using jet pump, you can see these two picture. One is for high volume artificial lifting mechanism. For high volume, you can see this gas lift will have very higher volume actually, and lift depth actually 16,000 feet. Okay, and volume flow rate 30,000. This is 20,000. This is 10,000. Okay, this is 10,000 line, this is 16,000 line, this is 30,000, this is 20,000, this is 10,000. Okay, so you see gas lift is having higher volume, and after that ESP will give higher volume, then your hydraulic jet pump. Okay, hydraulic jet pump is having higher volume, but if you see hydraulic engine pump, the volume flow rate will be much lower, but it will be going to higher depth. Okay, but hydraulic jet pump quickly the volume flow rate is going down. Okay, but if you have engine pump, then volume flow rate will be lower, but it will be fixed almost for longer depth. But lower volume of artificial lift, lower volume. Okay, so low volume, how this will work? 16,000. This is 10,000. This is 4,000. 2,000. This is 1,000. Okay. You can see this reciprocating hydraulic pump is having actually higher, okay, higher option. PCP is having lower than that reciprocating engine pump. Okay, reciprocating rod pump also having a little bit higher for larger water depth or fluid depth. Plunger lift is having lowest volume flow rate. So if you see this, if you compare the other artificial lift, actually gas lift is having the highest production rate, and lowest one is the plunger lift. Whatever discussion we are doing, maybe there will be much more artificial lifting system people are trying to develop every day, but this is the most common artificial lifting system, and we can compare based on this one for depth and flow rate. And power fluid, I already told that in one case, jet pump case, your fluid is mixing, but in hydraulic engine pump fluid is not mixing. How it is working? This is my casing, this is tubing, so casing is cemented here. Okay, okay, then perforation is here. Okay, so perforation is here, my tubing is here, so tubing, let's put on packer here. Okay, so annular is sealed now, there is no flow through annulus. Now I have to inject power fluid through this. Okay, my pump is here, jet pump. Okay, jet pump is here, so wellbore fluid will be going through this, and jet pump you are putting high pressure fluid, and these two fluid will be mixed up and it will be moving through this. Okay, and you take fluid out and you are giving power fluid conditioning. Fluid conditioning means whatever fluid you got from wellbore, you have to separate properly. Okay, then you create high pressure pump. High pressure. Okay, from high pressure pump you inject the fluid. Okay, so in this case this is called open power fluid option. Open power fluid means your fluid from wellbore, okay, and your pump fluid or power fluid, you are injecting, so the power fluid and your wellbore fluid mixing up together. So this is called open flow, right? Open fluid option. And one is closed fluid option. Open power fluid, open power fluid, OPF. Okay, CPF, closed power fluid option. In closed power fluid option, what you have? You have one wellbore again, like casing. Okay, then you have one tubing, another tubing is here. Okay, and you have one pump. Okay, so power fluid is coming through this. Okay, so power fluid is going back to this. Okay, again on surface you re-inject. Actually you do not need to condition again, because this is not mixing up with the wellbore fluid. So pump it. Okay, so but what is happening to your wellbore fluid? What is happening to your wellbore fluid? Wellbore fluid is coming, entering into wellbore tubing, and from tubing actually you are getting wellbore fluid like this. Okay, and this is your separator. Okay, so wellbore fluid okay, so hydraulic engine pump, hydraulic engine pump or piston pump. Okay, or plunger pump, hydraulic plunger pump or piston pump, whatever you give the name. So that pump will have power fluid. Okay, this is power fluid. Okay, power fluid is coming from surface, it is going through the pump, it is not mixing, rather it is going up to the surface, again recirculating, going like this. Okay, and if I see this wellbore fluid is going like this, and it is going to separator. So wellbore fluid is not mixing with power fluid, so life is easier because you got only power fluid which is circulating, not mixing with anything. So you do not need to separate the power fluid. But open fluid, it is for jet pump application. In that case, both mixing together. So in that case, you have to first separate, condition, then you have to put into your wellbore as a power fluid. Okay, so power fluid means whatever fluid you are pumping to your wellbore. Thank you very much.